work is building open source projects on hardtech or hardtech. It involves pain, it involves processes, and we will see if we can get eventual gains building these hardware projects in the open, and we can see how it goes along. I am Vipul, and I'm the product owner and documentation lead for Balina. I wear multiple hats in the consultancies work I do, and I run next to a documentation initiative to write documentation for startups. My pronouns are he and him, and the best way to pronounce my name is Vipul. And we'll be pulling in quite a bit of concepts today. What is MVPs? What are hardtech projects? How do you go on building these open source projects in the open? So you might have seen this green board somewhere around in your college life, in your work life. This thing is pretty much all over the world. It ain't much in terms of the processing power it caps or the amount of gigabytes it has in RAM, but it's a really useful device. It does quite a bit of work in our daily life. It is in satellites, it's in smart dustbins around your house, it grows our crops. These devices also run underwater drones, airwater drones, and now also in Dyson backpacks that you're going to have in the future. So while even smart cities and your toaster getting automatic updates, the challenge is going to be how are you going to build for this hardware? How is it going to be all working out? Because software development is already been hard enough. Building hardtech is downright painful. You can have issues like these in production, embarrassing issues, where things fail and you can't do anything about it. You have to code for failure, you have to code reliable systems so that they fail and they can self-heal, they can self-reproduce. And that's what hardtech projects are all about. And then we are also talking about how to open source them. So what is hardtech projects? Let's talk about that. Hard, as in difficult to build, not that tough, but also hard in terms of trying to see if we can get the concepts in. They're always in a niche, they're always building for a customer appetite that is not even there. Usually, hardtech projects, I try to describe them as something that change our perception of thinking. When one person decided that they will mass produce electric cars a decade ago, he was laughed out of the room. That was Elon. And then he went a bit crazy, but discounting that, he had a good idea, and that's what all hardtech projects start with. It starts with an idea or innovation that targets a niche and creates a platform for more and more businesses to operate on. It's much tougher, and it has its own challenges, but it involves hardware and software components coming together to solve a real world problem. And the challenges list goes along quite a bit. Projects have to be feature complete before even launching. You have to make sure what your target audience needs. You can't, just like software projects, you can't even launch a half-big MVP and decide like your consumers will buy the subscription and then you start getting revenue. Your projects have to be feature complete right from the get-go. And apart from the soft tech, the strategy needs to be not keep adding features, but stopping the feature creep, and rather than deploying the hardware out there. You need to target a special bit of customers because it's not meant for everybody. It's not consumer hardware that you can sell to everybody. It's only a couple of people who would need it and pay you quite a bit of money for it. And it has to be right. And there are a lot of challenges with it. Each iteration in hardware is quite slow. It's very expensive because you have to prototype every single time. And mistakes cost millions of dollars. So it's not like deleting the database tomorrow and the company will put a Reddit post on the internal channel. No, it will not happen like that. It requires full stack R&D teams and to tackle complexity both on the software and the hardware side. It requires scalability, IP protection, and a lot of mass production. And even then, you have problems like supply chain shortages and chip shortages coming into picture. And this is sort of the talk all about like how the scenarios are into building hardtech projects. And one of my favorite hardtech visionary products was Juicero, that you might have heard of. If anyone who has heard of Juicero, what is Juicero? There you go. Good. Juicero is a fun story. It's the funniest story in Silicon Valley. Juicero is a company that built a high-tech, Wi-Fi enabled juicer to hard press juice bags from scratch. They built and they poured resources into building something like this, something so complex that even hardware engineers all across the world were like, yeah, they did a good job. And then what happened is very peculiar. Someone released a video from Bloomberg where a person is just hand squeezing the juice. Literally. The entire job Juicero does, they do it better half the times. And that's where Juicero turned bankrupt. That very moment. And that looked okay until the Bloomberg employee released this. But the conclusion was the product was missing a market fit to test the core assumptions on actual target customers. They poured in $120 million over 2 years to build a complex supply chain and perfectly engineered juicer. That is too expensive, obviously. It was $400 when it retailed. It retailed for $800, discounted $400. When this video came out, no one wanted to buy it. So this is like one of the examples of hard tech being hard enough, and then if you don't have the market fit correct, or you have tunnel vision when building, or are you in an echo chamber in your own development teams where you're not getting enough feedback, you end up with Juicero. And if it's not hard enough, let me make it much more harder, where you have situations where someone parks the ship wrong and your company dies, because now you can't even get the hardware to build Juicero in the first place. Juicero would have been fine. And companies shutting down major hardware elements, or not even being able to buy major products to build your hardware elements. So, enough to say that the pain element I've covered quite a bit. Hard tech is extremely painful. But yet people do it, and people do it for some reason. So here's another Juicero, but a Juicero that works. So I work in Balena, and we make something called Balena Etcher, which you might have seen countless times if you are as operating systems. And we thought, a lot of people flash like one SD card or two SD card together to flash their operating system onto the storage. What if you build a device that can flash 16 devices at once? It's a premium product that a lot of people need in the market. The market is extremely niche, where each product sells for about $5,000, and this is going to be about $1,000 a pop. You can have this as Wi-Fi enabled, and you can have pen trays, you can have SD cards, the whole thing. It took us 3 years and $1 million in R&D. And that's like a team for 50 people. That's the story of HFO. That's how companies get it right. And if they do get it right, they get to reap the benefits, or they become the next Juicero. So hard tech is also embarrassing, not to say. Let me get back to my notes. And even though these are hard things to do, even though you can see I've put on a very negative show for hard tech projects, there are YC Combinator specifically aimed at targeting hard tech startups. You can see in the list, OpenAI is also there. It's one of those products, or it's one of those services that came up by Sam Altman only, who got funding through YC Combinator. So there is definitely need, there is definitely profit to be earned, but there is hard work to be done. And that's the process of us doing that hard work there. So the presentation begins with, now, as Jatin also did, so I did it again, how to build for hard tech and not burn down. It's the journey of open sourcing our own hardware project that I lead at Balena, and it's a journey of 5 years, $500,000 in R&D that I didn't spend, but still, it was good. Starting off, Balena has an OS called Balena OS. So a lot of people know Balena with just the Etcher, or just Etcher, not even know Balena. So we do Balena OS, and it's supported over 100 plus embedded devices. Balena OS is an embedded operating system that its only job is to run containers. With Balena OS, our problem has been, we support Balena OS on 100 plus embedded devices. That means we have to release 100 plus distinct OS releases for each device type. So let's say Raspberry Pi comes with a certain driver, Jetson devices come with their own sort of LT4X kernels. There's a lot of complexity, there's a lot of abstraction. And the problem was, testing all of this took a week and a half for one release only. So it was quite painful for our engineers, where testing looked something like this. We used to manually build the OS release on our laptops or Jenkins, then we used to flash it on a device. Our test engineer or test device engineer used to take a week or more to submit the results back to the team about the test they have created. Ajay, can you focus up? Don't talk. So our solution was, let's say we can automate all that. Let's say we can automate the sheer testing on operating systems on actual devices, where we have a worker, the tester, and a device under test. And what comes across is 5 years of a journey, trying to create this idea where we can automate a complete device, start flashing an operating system on it, run our test, and it can send the results back. The first iteration of our hardtech project comes across this. This is my Indian colleague. In 2016, when I was working in the company, they built a proprietary hardware, a test framework, and a jig, non-standard connectors to test this Raspberry Pi right here. In the bottom, with the hardware board right here. So the framework is always the same. There's a worker and there's a testing device. Next, when I joined Balina, you might expect, the coming of Christ. We'll fix all the problems. But this is the year we actually hit rock bottom. We were thinking of shutting down the project. It's not going well. But the company changed its name to Balina from Resin. And we built a standardized kit to test hardware and can now support any hardware that can take 12 volts. This was still very much proprietary. We built it for testing operating systems, but there's a lot of complex bits going around, and the entire hat that you see on the tester side is completely custom made. So scaling was hard. It was very expensive. I think one board cost like $1,000. And I can tell you, in short, we had to pivot into something better, something that could be used by the community, something that could be cheaper to come by. And that was open source hardware. A lot of the people might have heard of the term open source software, and open source hardware is very much similar, but it involves much more components to be open source and much more components to be openly available in the community. So we are talking hardware design, mechanical drawings, schematics, bill of materials, assembly guides, documentation, firmware, everything gets together. And imagine if a company spent $500,000 in R&D, would open source all that. Many companies don't. Many companies keep these things under proprietary conditions, never releasing them outwards, and there's still no standardized way to test embedded devices. Even with our thing open source, we are not standardized because Google, Microsoft, or every big firm doesn't use it. They have their own testing pipeline. So we decided to open source ours because the support has been quite the pain. Every time we had to support a new device on our AutoCAD, it used to be a full cycle of 6 months where we had to test the device, make sure it's testable, and then integrate it into our pipeline. So for you, how the testing progress looks like, let's say you want to open source some hardware, you select from the hardware that is already there in the open source, and it could be Arduino, it could be Adafruit. Lots of open source hardware already exists. A lot of open source components are already there by the community. You take up the feature set that you want, you prototype the need, and then you select what you want for your use case. You build on it. You document, you make sure it works, and then you release it back into the community for someone else to use. It's not just the fact about that you're losing money by open sourcing or giving the competitor an advantage. It's the fact that you are giving back to the community which you have taken so much from. Software, be it hardware, be it firmware that you create, anything that you give back is something very helpful for hardtech projects to come. Coming up next, this is what looked up in 2022, where we actually built out the entire pipeline and we had our entire projects done. This was a lot of effort, and we are coming into the portion where someone in the finance team or the CEO or the management team will ask me, hey Vipul, how much money was spent doing this, or how much money we gave out? And this is the bill of materials pipeline, this is the actual product that looks like, completely open source and off the shelf, no custom components, completely open source test framework as well. This is capable of testing all 100 devices that is supported at Balina, and it saves up to about 1,000 engineering hours per month by automating every OS release that we do and gets tested on an actual device type in a rig that looks something like this. We went in, this is sort of my baby, if I like to call it. And we went into Athens to build this rig. This is completely full now with all the devices that we support. Each time a person opens a pull request, we use that pull request onto these builders and then start testing. Once the test completed, the feedback comes back to the PR, and then the OS engineers know that the build works. No human intervention allows because humans suck at testing. We can't be kept reliable for testing, so we have to automate quite a bit of it. And that's where we are, where the entire rig is now there to test whatever we want. But we wanted to go further because of the open source hardware that we have created. We wanted to read the feedbacks, and the results were PRs coming in almost weekly by consumers, by CDS partners, by our own customers, where they're adding new device support to our hardware, to our own hardtech product. They're trying to make it better because that's what the community works for. So in the end, I had something to say and I saved my neck in the company, where we have actually turned quite a bit of profit in the community contribution side. We have a lot of emails coming in as we deliver talks and share these sessions across the world, where we have built this, what you have built, and we come into a conversation where people are really interested in seeing if we can build something standardized, and we are trying to create a hardware in the loop testing community out there. You have white papers written, you can have research studies done where people in big tech companies can also come in and check out your plan and start building their own thing on top of it. And you can go out and give a talk proudly about a thing that was completely proprietary, that you open source, and now it's available all over the world. Benefits of open source hardware. Quite a bit. I don't like inventing the wheel. I'll share the slides, but there are tons of benefits for businesses, for science, for even students who are like you, who want to get into open source hardware and trying to make your mark into it. There are several things that makes the iterations easier. 3D printers have cut down the cost. From about $20,000, you can now have your own 3D printer. You can even have PCB printers now that you can buy. Or you can give your circuit board designs to companies like Rogu, where you can publish or print your PCB manufacturer. So you don't even have to do it for yourself. Lots of vendors will do it overnight for you. And lots of expertise is out there, a lot of shared pooled expertise because of the open source movement in hardware that makes hard tech easier for all of us. But once we take one step forward, the Indian customs hold us back a little bit, where situation is like they hold us back on boards or they charge a lot of customs on it. But things are improving. Once the red tape of the bureaucracy improves, maybe they return one of these boards. Coming on to building the software for the hardware, which is something that a lot of us are involved with. Sure, hard tech is like really specialized or really scenario specific, but you can actually work towards building or playing your own part in the software development lifecycle, which is something that you might have seen in your own textbooks when you were in college. But an IoT lifecycle or a hard tech lifecycle looks something like this. You have added stages of selection of physical IoT hardware, modeling the physical IoT hardware, and then setting up the communication and setting up the environment. Anything that goes wrong in these first few steps will result in failure of your project. So no pressure. It will end up all right. It's all testing and experiments. And once you have built, you can build reproducible self-healing setups or build fault-tolerant applications that will be easily deployed and won't result in the embarrassing moments that we've shown earlier. This is my favorite part of the talk. How do we use it at work? How do we use it right now in schools, where some people would be interested in building hardware, some people would be interested in building software for the hardware. One is like you start working with the right companies who are building these projects already. They have the capital, they have the skills, they are looking for people who are really involved. This is how I got involved in a company similar to this, where if you show true appreciation for the work that is happening, they'll happily help you, train you, and make you, participate into their projects. And there are multiple ones, multiple open source hardware companies as well, like Arduino, and lots of hardware companies that want people like you, new people who are coming in with new ideas and new energy, because most of the kernel community is quite old, and we do need more Linux maintainers, more hardware maintainers out there. And I can keep going on, but it's not going to be easy. No one wants to give things away for free. But that's what the open source spirit or the open source movement is improving on. Not free anywhere, but take steps to become open source friendly in your team. Start the conversations. Make sure you get those discussions in line to start making those moves so that you can become open source in both software and hardware. And I can keep going on, but it's a brief problem. It's something that we are tackling quite a bit. And there's a lot of things to consider when building IoT applications, but that's all we have time for. And I would like to leave off with one quote that I was researching and it struck with me. Software may kick off many opportunities, but industrial revolutions come from the innovation in the physical world. No matter how much AI models that we build, or how many edge computing networks that we create, all of it runs on some hardware somewhere. It's not hardware in your home, it's hardware in the cloud, it's a computer somewhere in the cloud, right? Working on the hardware could be a very good field going forward, where everything is going to be dependent on edge. where on-compute basis and on-prem will be the actual tokens differentiating companies. So yeah, lots of good things to come, and that's about it. Thank you for listening. We can take questions, and for people, I've included a lot of links. There are a lot of credits as well in these slides. So you can take this QR code. It's an optional feedback form as well, so you can just fill that up or just click submit to get the link in the end. But if you do feel submit, this is something that I do like where people can ask questions or even put their questions over on this form. Thank you. And any questions? Going once, going twice, done. Thank you.
Yeah. So I have.
Oh, sure, please. No, don't want to do the auction once.
Yeah. So like I said that we are benefiting from like open source hardware. I built something on ES70.
Yes.
Because of open source hardware. Now I want to convert it into a solid product PCB or something. So how should I approach it? Should I solve the Arduino to that PCB? Because we have like proprietary microprocessors now, ARM-based IC. How should we approach to finalize that project? If we have like a dummy project, we have connected to like breadboard and jump wire. So how should we finalize, productionize that?
So in that flow, so just for someone to hear the question, the person in front is asking, how do we finalize once hardware project is built? Or once an open source hardware is built, how do you go forward with production, right? That's where I would say comes the YC Combinator guide that I was reading last night. And it says like, try to find the least or the smallest market fit that you can for your products. So once you find the customer base, you will be able to scale it according to that. You don't have to find how to scale that in the production capacity, but you can, if you find the use case, you can make sure you can grow your product. But in terms of manufacturing, which is something that you would like to know, there's a lot of projects and there's a lot of companies actually called M-Hub, YC Combinator, Multiply Labs that will happily build you the PCB or the design that you want on your own. If you want 1,000, they have like an MV minimum order quantity, MOQ, for about 1,000 devices. So if you have customers for 1,000 devices that you can sell, go for it. And people also have like less MOQ and they can do it for lesser. You don't even have to pay quite a bit of prices for it. And you can give them the design files, and some of them are really helpful as well, where they'll even go forwards and help your design improve. So let's say you mixed up some capacitor voltages or you mixed up some resistors in your circuit board, they'll fix that for you as well, free of charge. And that's the services that are out there. Back in the day, this was not existing because only a few big companies used to target this entire field. But now it has become more and more democratized. A lot more smaller players can enter into the hardware. I saw on Instagram once where some person is building a keyboard from scratch and then selling that. It's called Work Louder. Some people might have seen that knob keyboard with a screen on it. Pretty good. That guy, I've been following their Kickstarter journey for that, and that guy has been working for just a year. Imagine. From design to production to selling. Lots of avenues are there to sell your product out there. And if people are there to buy it, they'll happily fund it as well. Because something I missed in my slides was, hardware projects are incredibly sticky. If you find a product that sells, people don't lose it. People stick with it. They'll want 1,000 or 10,000 worth of quantity, and you can charge them a subscription of maintenance, support, updates. And it's a really nice business model. That's why I missed that point. That's why YC invests quite a bit of it. The gross margin for a good hardtech project is 1000x. It is basically a good way to churn money. Not churn money, build money. Churning is good. Anyone else with questions? Go for it.
So sometimes like Raspberry Pi phone is kind of out of stock or not available. So is there any alternative to you so that I can like, get started with hardware?
Sure. And this is the case everywhere where after the chip shortage, the person's question was if Raspberry Pi 4 or something that you want to build with is not available, which is sometimes it happens where boards are just not available. Right? There are many alternatives out there where you can start testing or building with. You can use a board with a similar architecture. So, and Raspberry Pi 4 is ARM v7, or no, it's ARM v8. So you can use a different ARM v8 board to build your hardware with. There is NanoPi, there is BeagleBones, lots of them using the same architecture. It totally depends on why you're using a Raspberry Pi. So if you don't find one out there in the market, you can also ask friends. A lot of people are holding Raspberry Pis. I also have some. So, because we hold them because we can't find them. It's exactly how water is being hoarded in Bangalore. Another joke. But yeah, dire circumstances versus SBC, not equivalent. But to answer the question, there's multiple alternatives to hardware. You can always find something out there in the market that you can use. There is actually a very good resource I can link for alternatives, which will just give you an alternative of a particular board. Yeah. Hopefully that's helpful. Any other questions? Going once. Okay. Time over. There. Thank you.